Hello and welcome. We'll be waiting for a few minutes and to start. So until that happens, until we start with the program, I want to welcome everyone who's already here, who's joining. A little bit about myself. I'm a Svelte enthusiast. I love Svelte for its simplicity and its design approach about being a compiler and having minimal JavaScript on the website. The approach of progressive enhancement is also something that is really dear to my heart. So users, when JavaScript fails, will still be able to use the website. So that is really important from a user experience perspective. So inside of the JavaScript Competency Center chat, there's also a little Svelte chat. So if you want to check it out and just say hi or leave any questions, I'll be happy to answer and chat with you about Svelte. I brought a special guest with me today, which is Ivan. He's also a Svelte enthusiast, and he is working in open source. He has worked a lot with Svelte and TypeScript. And one topic that is really dear to his heart is developer experience. This will be also part of the topic of today. And yeah, maybe Ivan, can you tell us for how long have you been using Svelte?
Yeah, quite long. I already joined the Svelte developer experience when Svelte version 2 was released. So I don't really remember, I think 4 or 5 years ago.
Yeah, so you have seen the tremendous growth of Svelte happening in real time. You have probably also jumped into some Svelte beta stuff when SvelteKit was still not 1.0. So yeah, how was that for you?
We had it running in 2 production applications, larger production applications, even a year before it was released. So we had to go through a lot of breaking changes, but it was really worth the effort, and the apps are now really good.
So excellent. Yeah, thank you all for joining the stream. And I guess I'll hand over to Ivan and yeah, talk about and show us a little bit about exceptionally and how to handle errors and exceptions in your JavaScript code base in a type-safe way.
Exactly. So yeah, like Dominic already mentioned, today I will show you how you can make error and exception handling fully type-safe. I will show you a basic example without any exception handling, and we will iterate over the code until we have a solution that has strong TypeScript support. But first of all, we need to define what an error is. So for me, an error is unrecoverable. An example would be if you start your application with missing environment variables, then the application can't really function correctly. And the expected behavior is that your application then crashes. On the other hand, we have the exception. Exceptions are mostly temporary or input dependent, and only affect a small portion of your application or a small amount of users. So an example would be when your payment processor is down and newly registered users can't subscribe to your services. All other users are not affected by this issue, and the expected behavior is that your application should continue to function. And in the context of this talk, we mostly speak of exceptions. So let's take a look at our simple example. Example application. Here we have the dashboard, which shows us that we have 100 posts. If we click on that link, we get a list of all posts and their titles, and we can also click on an entry to see the details and also the corresponding comments that belong to that post. If we now take a look at the code example, at the code, then we see that it is a SvelteKit project. If you never have tried SvelteKit before, you should definitely do it. And here we see the routing structure of our application. And in our page.server TS files, we load our data from our database servers. For today, we will just focus on the server code. We don't touch any Svelte-specific features. And this also means that this concept that I show you today can be applied to any other framework. We can run the svelte check command and see that we don't have any issues here. Svelte check checks the code base for TypeScript related errors. So we don't have any errors. Perfect. We can push this application to production, right? Not really. As an experienced developer, you may know that accessing data from a database like we do here can throw some exceptions, but TypeScript does not help us here. You need to know where something can throw, and you also need to know how to react to it, and also what kind of exception got thrown. We can take a look at the database service. It's just a simple implementation. It makes calls to our REST API, and it just returns that data and parses the JSON. To simplify our lives a bit, I have created this typed JSON fetch function that wraps the data fetching functionality into a generic function. And if you talk to an external API, you should always wrap it into some generic function to keep the actual call logic simple and dry. So what can actually go wrong here? We have probably a delay in our stream, so I will answer the question myself. I have prepared an example that captures some of the errors that can go wrong here. So first, we can have some kind of network exception. Maybe the internet connection is bad and your network fails. So in this case, we return a new error with this error message. Then the response also could be the API that you are calling could respond with a non-200 status code. In this case, we catch that and return and throw another error. Then also the JSON parsing could fail. The endpoint could return invalid JSON. We will catch it here and throw a new error. And you should probably also check the data that you access from an API matches your schema. So whenever you are talking to external services, make really sure that the data you receive matches the schema that you are expecting. This now is just a dummy function, but you should get it. And at the end, we return our data. And yeah, that's it. So we have 4 different exceptions that can happen here and one successful case. So if we hit save, Svelte check tells us that we don't have any errors. So wait, we throw errors everywhere, but don't get notified a bit about it. Yes, that's the case. And in my opinion, this is also really bad if you work within larger applications. You need to know implementation details of functions you are calling in order to be able to really know that your code is safe. And in larger applications, you probably won't write everything in a single team. Parts of your application might come from other teams. And whenever you update a dependency whenever you update a dependency, you would need to take a look at the code or read the changelog in order to know if a change affects your application in a bad way. In our application, Svelte handles this for you. All errors that get thrown will simply result into a 500 error. So it does not crash the application. It just affects the current request, which is good. And in other systems, the whole process could crash if you throw an error somewhere or an error gets thrown by some library you use somewhere. And you need to make sure to restart the application in order to process upcoming requests. So what do we need to do in order to know that something can go wrong? We need to return errors instead of throwing them. There exist a couple of approaches that do that. And the approach I see most often is the data and exception tuple. So let me just grab that. In our successful case, we always return a tuple, and in the success case, we return our data as the first element of that tuple and undefined as the second one. And in an exception case, we return undefined as our first element and the exception as the second one. So let's update this example. We need to define the return type. Here we return a promise. Our result can be a data or an instance of an error class. Then instead of throwing, we need to return undefined as the first element and the error as the second one. Here we can't use it inside this catch block. We need to wrap it outside and check if we got a response back. If not, we know that we entered this catch block and then we can handle it as an error. We do the same here. So return undefined. Also here, we need to do it outside. So if we don't get any data back, we return undefined and our error class here the same, return undefined and here. And in the success case, we have seen before, we return data as our first element and undefined as the second one. We now hit save and we immediately got errors because we haven't really updated the places where we use it. So let's do that quickly. If we hover over number of posts, we see that we got 2 back. It's not really what we want. It's we actually want a number and not 2. 2 is actually the length of the tuple that we return. So we go into this implementation and see that we are not handling the result that we get back. So let's quickly do that. We get back a tuple with our data and exception, and we check if it is an exception. Then we just return undefined as a first element, and we just pass the exception for now. We need to use as const here. And in the success case, we return data dot length here and undefined as an exception. And we also need to use as const here. So whenever you use tuples, you always need to use as const to tell TypeScript that we want to treat it as a tuple and not as an array. The reason why we didn't need to do that here is because we manually specified the type, the return type here on top. So let's go back to this here. We can destructure the number of posts and see we now correctly get number or undefined back. And we now can just check if the data is here. If the data is not here, then we throw an error. And in the success case, we return the number of posts. Let's do that for the other functions too. And also here. And this one looks a bit weird because we get, or this promise.r, we are awaiting 2 synchronous function calls. And we get back an array of tuples. So we can destructure it here, and luckily TypeScript knows it, and we see that we get the data that we expect here. So yeah. So here we can actually throw the error, or throw. We don't do anything with the exception right now, but here it is safe to throw an error because here we are leaving the boundaries of our application, and SvelteKit actually expects that we throw something here if something goes wrong. And in your internal code, like we saw before, in all those database function calls, you should never throw something, and you should always return exceptions instead. And perfect. So now we got rid of all errors, and that's great. But now we have introduced another bug here because we were a bit lazy. So if we go back to our dashboard, and if this function call would return null here, then we would get we throw a 500 error. And that's because we are checking if this number of posts is truthy. What we really should do, and what some people might miss, is that we need to always check for the exception if it is here. So let's change that quickly. Exception. And if we hit save, now we have fixed our example. So let's fix it quickly here too. Exception. And also here. So here we already have a conflict because we cannot name the same or two variables the same. So we need to name it like this. For example, here we have a post exception. Here we have the comment exception, and let's check it here, post and comment exception. But now TypeScript is confused. We are handling the exceptions, but TypeScript still thinks that this post variable can be undefined. So we actually need to destructure it like this. So instead of directly destructuring it here, we have to define a variable and destructure it in a second step here. And now we got back our type safety. So let's check our application again. Perfect. If we access the post with ID 203, we get a 500 error back. So 500 means we have an error on the server. But is this right? Not really. I know the data set, and therefore I'm also aware that only 100 posts exist. So accessing any other ID should result into a 404 error. So we need to distinguish between different exceptions. How do we do that? Sure, we can check it here. So check for the error, for the message property on the error, but it feels a bit weird to check to compare strings. So what we really want to do is define classes for all exceptions that can happen. So I've created a few of them. So here we have the network exception, fetch exception with the HTTP status code as a property. We have the JSON parse exception and also the validation exception. The reason why we have to define here a property is because TypeScript gets confused if we compare different error classes or different classes that derive from error. So we need to define a property that is, so TypeScript can distinguish between the different exception classes. So let's do that now. Let's update our code. First, we need to update it here. So we don't get, or we don't return errors. We return a network exception or a fetch exception or a JSON parse exception or a validation exception. And we, of course, also need to update it here. Let's do that quickly. We can get rid of the string that we are passing because the class itself tells what kind of exception happened, and manually defining a string everywhere where you want to return this exception doesn't really make sense. JSON parse exception and also the validation exception. And now if we come back to our example here, we can just use the instance of operator to check if the post fetching the post resulted into a HTTP or a fetch exception. And we return that instead. And if we hit save and go to our page, we now finally got our 404 error. I have worked with this system for a few weeks, but for me it seemed not really ergonomic enough. I already showed you some things like you have to manually tell TypeScript what type you return inside the tupper. And this destructuring and naming of variables, I find a bit odd. But the real deal breaker for me was that it doesn't really enforce you to handle exceptions. We saw before here with the number of posts issue that if we don't really pay attention and check for the exception, then it can result into a bug. And I have thought about a bit about this process, and then I came up with my own approach. I have released it as a library, and it's called exceptionally. And let's install it and see how it works. So if we go back here, we can get rid of this, of manually defining the result type here. And instead of returning a tuple, we use two of the utility functions that come with the library. In an exception case, we wrap our return with the exception function. We do that for all our exceptions. Just one to go. And in the success case, we wrap it with the success helper. If we check our code again, we of course get errors because we changed the implementation. And here we see the first error. So instead of a tuple, we will get back a result. And we can check if it is an exception by calling result.isException. If yes, we just pass along the result because we don't want to handle it here. And in the success case, we unwrap the data we get back here from the result. We can access the length attribute here. And we need to wrap it again with the success function. And here we have to do the same. So we get back a result and we check if the result is an exception. If yes, we throw, and our number of posts is the unwrapped value of the result. Let's copy it over here to be a bit faster. And also here. Perfect. Now we have replaced everything. You may think, yeah, nothing really special, right? Well, the library comes with additionally with some utility functions that make the usage more convenient. And I told you before that I didn't really like that you're not enforced to handle exceptions. but with exceptionally you are. If we comment out this exception handling code, we immediately see that we don't return a post, but we return a post or one of those exception classes. If we comment out this, or if we comment back in the exception handling code, then we see we are sure that here we are only dealing with the post and we have handled all exceptions. So can we also improve this example here a bit? Yes, of course. So here we are fetching from two different functions. What if we want to fetch from a third one? We need to add it here. A new entry here into the array. We have to destructure it here. And you probably will forget to also check it here. But like I said, this is not a big issue because when you try to access the value, you will immediately see that you forgot to handle the exceptions. And what I really don't like about this solution here is that it adds a lot of boilerplate code. So that's why I also have created a utility function. I called it process in parallel. You can pass in as many function calls as you want. In the end, you will get back a single result object. And if one of those function calls returns an exception, then this exception will be true. We can iterate over those functions and over those exceptions and check if one of those exceptions resulted into a fetch exception. One of the next improvements I want to make to the library is to create a convenient function for this, so you don't have to write that much code just to check if one of the exceptions resulted into is an instance of a certain class. And here at the end, we can destructure our successful result and we get back full type safety. So we never have specified any type. All types were inferred automatically. We can also use other utility functions, for example, to check if we have handled our exceptions. I have prepared another example here. So with guard success, we can make sure that we have handled, that we really have handled all exceptions. If we comment out this code, then we immediately get a TypeScript error. This all happens on the TypeScript level. So when you compile this code, this function actually does nothing. It's just here to help you in your IDE to immediately spot issues or potential bugs. And here we have also another reason why we should return different exception classes. Maybe in some parts of your application, you want to implement some fallback behavior. You could implement a retry logic like here. But this only really makes sense if we are dealing with a network exception. So if the result or if the value, if the exception returned from here results into a 404, then retrying it every other second doesn't really make sense. So only if you have network issues, this makes sense. So here we handle or here we handle the network exception case and we hover over here, we see that only 3 of those exceptions remain. So TypeScript narrows it down for us. And at the end, when we think we have handled all our exceptions, we can call the guard exception handled, and we will get notified if we forgot something. So let's quickly change this. So instead of a validation exception, we return a string here. Then we immediately get an error because we forgot to handle the string case. So yeah, that's great, right? Let me switch back to the slides. And I have a fun fact for you. Do you know how much the core of this library adds to your bundle size? Just as much as it takes a PC to save this paragraph on disk. It is about 132 bytes, minimized and gzipped. In the end, it's just a few lines of code with some TypeScript magic on top. This is the full implementation. Well, just the JavaScript part of it. It has about 15 lines of code with additional 4 times as much TypeScript annotations. If you really want, you can easily implement this yourself. After I have implemented the first concept of this, I looked for existing libraries on NPM. I found a couple of them, but I didn't like them that much. So I continued working on this concept and have released it as a library. So what are the advantages when we return exceptions instead of throwing them? The code flow stays linear, so you don't need to wrap everything with a try-catch block and so on. We get full TypeScript support, and the types can be auto-inferred, and you don't need to know about the implementation details to see if exceptions are unhandled, because if you return something, then TypeScript knows what all possible outputs of that function can be. And this is a really huge help when refactoring your code, and of course also while writing it. There also have to be some disadvantages. There's a small learning curve when using such an approach. You need to wrap everything with a success or exception structure. And this could be solved with a proxy. I didn't cover it today. It only supports code that you own. External libraries will probably not use this approach. But when you are calling a function from an external library, you can easily wrap that functionality like we saw before with this typed fetch function. So have you heard about the shift left principle? The key message is that you should resolve issues as early as possible. When we apply this code, this concept to coding, the first moment where this happens is in our brain. So the more we code, the more things we have seen, and we can already write code that is less error prone. The next moment would be while we actually implement the functionality. With static code checks, we immediately see that something is wrong. Next would be when we test the code manually. So you click through the UI of the application, and in a few seconds, you realize that something is wrong and you need to fix it. Once you push your code, automatic tests in CI can catch issues and that you didn't see before. But at this time, you already need to wait a few minutes for the feedback. The next moment would be in your staging environment when someone else tests your code a few hours or even days later. And the last moment where something shows up would be in production. And if it happens on your production system, then it may also lead to data inconsistencies. So you need to additionally fix the database, and yeah, you should get it. If you catch bugs early as possible, it will reduce a lot of efforts and costs. And by returning exceptions instead of throwing them, you can automatically catch bugs here and also here. And the reason why you probably won't catch all issues while writing the code is because your IDE only checks for errors in the files you have opened and not for the whole code base. So if you don't run the TypeScript compiler locally, then you need to wait until CI checks your full code base. But having to wait a few minutes is certainly better than having to wait for hours or even days. So let's summarize a bit what it means if you stop throwing exceptions. Will your code be bug safe? No, but it's the same as if you start converting a JavaScript project to TypeScript. TypeScript will not help you if you type everything as any. So if you still write the same code, you will have the same bugs. But if you use the available tools correctly, it will make you aware of potential bugs. Can you ignore writing tests? I would say no. But I would say that you need fewer of them, especially a lot of integration tests can be eliminated because static type checks will already catch the issues. Does it replace error reporting services? No. There could always be cases where you forgot to wrap something or where you use the tools incorrectly. So having an error and exception reporting service as a fallback is always a great idea. And should you know the implementation details of a function you use? No. You should be able to trust the function to do what it says, and TypeScript should tell you what all possible outcomes can be. So by accessing this QR code, you will be redirected to the GitHub repository of Exceptionally. Try it out, share your feedback, and don't forget to start the repository. I have also published the code of this talk here. And you can find more projects I'm working on by accessing my GitHub profile. 2 projects that I shortly want to mention are TypeSafe i89. It is a lightweight and fully type-safe internationalization library that works with all frameworks. And also the TypeScript, the Svelte TypeScript showcase, a collection of examples how to use TypeScript within Svelte. Currently, the official documentation lacks some examples for now. And if you start working with Svelte and you don't know how to type something, you will probably find the answer here. And yeah, that's it for my demo. I hope you enjoyed it, and I'm happy to answer any questions you might have.
Yeah, thank you, Ivan, for giving us so many great examples. Maybe I'll start off with a question here. Have you ever refactored one of your projects with Exceptionally?
Yes. A few weeks ago, I had to refactor, what was it, about 50, 60 or 70 files. And with 4 different modules. So I, yeah, just by using exceptionally, I saw, or I caught a lot of issues that else I would not have.
Very nice. So we have a question on YouTube. Is there any specific reason not to use try-catch in util TypeScript function? And thanks for the presentation also from Eugene.
So you mean here, so we are catching or using the catch function instead of the try-catch block. You can do the same with the try-catch block here, but I don't really like the additional indentation and the boilerplate code that gets added just by using the try-catch block. I think it is about 5 lines of code that will be added to that function. And wrapping the full example into a single try-catch block is also not a good idea, because you don't really know if it is a network exception or a JSON parse exception then.
Yeah, I hope this answers the question. So I guess to summarize, it gives you a better context of what exceptions you're experiencing, and you have the possibility with TypeScript to keep it to make sure you handle every one of your exceptions specifically. So I think we have 1 or 2 more questions. Well, 1 more questions from YouTube again. Was it hard to convince customers to publish your approach as a library?
It's most.
So they published it. Mm-hmm. So after you're gone, they kind of depend on you, even if you're no longer on the project. I think that's the question.
I'm the tech lead, or I was the tech lead of the project, and I didn't want to deal with all the things, all the bugs that can happen, and I made that or I suggested that we use something that works better than the current system, and we all agreed that something needs to happen, and we agreed on that library. And yeah, it doesn't really depend on me, or it would be the same if you would use some other library. You can't really trust that this library will be here in a few months from now. So I don't think that's a valid reason not to decide against against a library. If it works for now, then yeah. And like you saw before, it is not that much of code, so the dependency is not that huge.
Yeah, so one thing you didn't mention, I think, was that, I mean, it is really, really lightweight, the core library with 132 bytes, but it also has no external dependencies. So that is another thing that is also really helpful. So you can take those few lines of code and do your own implementation. And yeah, I think the pattern is really great there and really useful. And if you need a more custom a custom solution that fits better to your purpose, I think then it's really easy to implement it yourself.
Yeah, you can wrap the functionality however you like. So if you one, if you don't like that this card is exception, then you can wrap the functionality and name it however you like.
Yeah.
Or just copy the code and alter it. So
yeah, so I think I don't see any more questions popping up. So I guess, yeah, maybe any last words from you, Ivan, before we finish off?
yeah, try it. If you ever had some issues with thrown errors that you didn't handle or forgot to handle, then this is certainly an approach that you should try out.
Yeah, thank you so much, Ivan, for joining us today. And thank you for the great presentation and a lot of examples and letting us see how you think about exceptions and errors. And yeah, thank you also to the audience. Thank you for joining. And yeah, feel free to reach out in the Svelte channel or leave comments on the community page. Thank you so much.
Thanks.